Hi, Mr. Richards here, and today's lesson is on rational exponents. Our objectives are to evaluate and rewrite expressions involving rational exponents, and then take that to solve equations involving expressions with rational exponents. Our first example and our first key concept deals with b to the 1/2 power. And when we have, as long as it's a non-negative real number for b to the 1/2 power, that simply means the square root of b. So 16 to the 1/2 power is the square root of 16, which we can simplify to 4. We could also go, okay, 38 to the 1/2 power is just the square root of 38, which we cannot easily simplify, so we would just leave it the square root of 38. So in our directions, write each expression in radical form or write each radical in exponential form. So we have 81 to the 1/2 power. Well, this we can rewrite as the square root of 81. And can we simplify the square root of 81? Sure. That is 9. Now, what about the square root of 38? Well, we're going the other way with this now. We're just going to rewrite this as 38 to the 1/2 power. What about 12 times m to the 1/2? Well, it's important to realize that the 1/2 power is only being applied to the m. It's not being applied to the 12. So this is just 12 times m to the 1/2 power. The 12 kind of stays out of it. So this is going to be 12 times the square root of m. And we don't even need that multiplication sign there. We can just write 12 with the square root m. Now, what about the square root of 32w? Well, this is all grouped together, so we can put the 32w in parentheses and take that to the 1/2 power. Now, nth roots can be slightly difficult without a calculator, and you can use a calculator on these, but for any real numbers a and b and any positive integer n, if a to the n equals b, then a is the nth root of b. Well, let's go right to our example for this. Because 2 to the 4th is 16, 2 is a 4th root of 16. So the 4th root of 16 is 2. I mean, it's like saying, all right, since 2 to the 3rd power is 8, then the cubed root of 8 is 2, or the 3rd root of 8 is 2. And so when we look at our examples for the 4th root of 256, well, this can be rewritten as 4 times 4 times 4 times 4. 4 times 4 times 4 times 4 is 256. And that's the 4th root of it. And so that is just simply 4. The 4th root of 256 is 4, since 4 to the 4th power is 256. It's kind of like undoing square roots and squares. It's just with 4th roots, or 5th roots, or, well, in this case, 6th root. The 6th root of 15,625. Now, if you're looking for where do I even start, let this 25 be your example or a guide. It'll help you lead you to 5. I mean, 5 squared is 25. 5 to the 3rd power is 125. 5 to the 4th power is 625. Notice that all your 5 to the powers seem to end in 25. And so if you see a root with 25 in it, let that lead you a little closer to 5, and you can test it that way. Now, I forgot to include example 3 in our template here, so example 3 deals with the concept of b to the 1/nth power. And this says that for any positive number, or any positive real number b, and any integer where n is greater than 1, b to the 1 over n power equals the nth root of b. Notice how the n is the nth root and b is your root. So an example of this would be 8 to the 1/3 power. And 8 to the 1/3 power would be the 3rd root of 8, which is just 2. And so that's the key concept there. Now, for our additional examples, we're going to be asked to simplify. In an example A, it would be 1,331 to the 1/3 power. Well, for this is going to be the 3rd root of 1,331. And that is simply 11. For example B, we have 2,401 to the 1/4 power. Now this is going to be the 4th root, notice how we took that denominator, of 2,401. This is simply 7. And yes, you can use a calculator on these. Now example 3 builds into example 4 where we have b to the m over n power, not just 1 over n, but m over n. The difference here is your denominator is still going to be that root. It's still going to be that root. The difference is the whole thing is now going to be to the m power. So 8 to the 2/3 power. Notice how the denominator still goes to the 3rd root of 8, which is just 2. And then you take 2 squared because of the numerator there, that goes there. And 2 squared is 4. Now the best way to do this is to look at some examples. And so we have 32 to the 2/5 power. Well, we can rewrite this. I'm going to rewrite this here and kind of color code it to help us out here. This is 32 to the 2/5 power. Now, this is going to be equal to, in parentheses, we'll draw our radical sign, we'll put our 32 on the inside, and this is again going to be to the denominator root, and that here is 5. And the whole thing is going to be to the numerator, squared. Now, the 5th root of 32 is equal to 2. And we're going to have 2 squared, which is just 4. Now what about 81 to the 5/2 power? Again, let's color code this to try to make it a little easier to see how these numbers are going to be moving around. This is going to equal, in parentheses, we can draw our radical sign and put the 81 on the inside. It's going to be to the denominator's root, so the 2nd root or square root, to the 5th power. So the square root of 81 is 9 to the 5th, and 9 times 9 times 9 times 9 times 9, I think I got them all there, is 59,049. So 59,049 is your answer for that. Let's move on. Now we get to solve equations using these. And in words, for any real number where b is greater than 0 and b is not equal to 1, b to the x power equals b to the y if and only if x equals y. So if 5 to the x power equals 5 to the third, then x is going to equal 3. Now, what are we going to do with 9 to the x equals 729? Well, let's try to get our 729 down to something involving a 9. Well, 9 squared is 81, and 9 to the third power is 729. So we can rewrite this as 9 to the x power equals 9 to the third power, since 9 to the third power is 729. Now, what this property is saying is, well, I have the same base. So I can simply set my exponents, my powers, equal to each other. X equals 3. And that's my solution. X equals 3. Now, 16 to the 2x minus 1 equals 8. A little more complicated. Let's try to find a common base here. Now, I know that 8 can be rewritten as 2 to the third power. I know that 8 can be rewritten as 2 to the third power. Can I rewrite 16 as something 2 to the something power? Well, yeah. 16 is simply 2 to the fourth power. That's the 16. Now, what I need to do is wrap this in parentheses and take that now to the 2x minus 1. So I have 16 being 2 to the fourth, and then the 2x minus 1 comes back down, and 8 is 2 to the third. And now I have the same base. But before I set anything more equal to each other, I need to simplify this. Well, power to a power, we multiply the exponents. And so this is going to be 2 to the multiply 4 times 2x, and you would end up with 8x, minus multiply 4 times the 1, and you get 4, equals 2 to the third. So what we did there, we did power times the power. 4 times 2x minus 1 is 8x minus 4. And now that we have a common base, and our exponents are simplified, we can set 8x minus 4 equal to the other exponent, 3. And now we solve the two-step equation. Add 4 to both sides. $8x is going to equal 7. Divide by 8 on both sides. And we now have our x simplified down to 7/8. And that's our solution. X equals 7/8. Now, how can we apply this in a word problem? The population P of a culture that begins with 40 bacteria and doubles every 8 hours can be modeled by the equation P equals 40 times 2 to the T over 8 power, where T is your time in hours. Now find T if our P is equal to 20,480. Let's start by rewriting the original equation. P equals 40 times 2 to the T over 8 power. Now, we're given the P, so we can substitute in for P 20,480 equals 40 times 2 to the T over 8 power. Now, we can actually simplify this before. We can divide by 40 here on both sides. That simplifies. On the left side, 20,480 divided by 40 is 512. And that's going to be equal to what's left on the right? 2 to the T over 8 power. Now, I have one base at 2. My 512 I can actually rewrite as a base with 2 as well. 512 is 2 to the 9th. And that's going to equal 2 to the t over 8 power. And now that we have our bases the same, we can say, all right, 9 is going to equal t over 8, or t divided by 8. And to simplify this, all we need to do is multiply by 8 on both sides, as this will cancel, and we're left with 72 equals t. So our answer, since t is in hours, is 72 hours. So one of the keys as you're trying to solve these equations involving exponential, look for the same base. It may not be real obvious right away, but here we have 2 to the t over 8 power. See if you can get that 512 to be 2 to some power. Guess and check, 2 to the 5th, 2 to the 6th, 2 to the 7th, until you get it to be what you need it to be. That is it for this lesson. Good luck.